titled Innovative Ways to Leverage Smart Communication Platforms to Deliver Operational and Customer Benefits. A few housekeeping notes we'd like to mention. For best results in viewing this presentation, we recommend using a wired, high-speed internet connection, as wireless connections can be unpredictable. If you cannot get adequate sound from your computer speakers, you may dial into the audio portion using the telephone number listed in the right-hand panel of your interface under the audio section. Following the presentation, we'll have a brief question and answer period. You may submit your questions at any time using the interface on your screen. Happy to introduce today's panelists. We have Lainey Brown, Director, Smart Grid Planning and Programs at Iberdrola USA, and Chris Bull, Global Program Director for Trilliant Networks. I'm now happy to turn the floor over to Chris Bull, our first speaker, to kick off today's event. Chris, welcome to the event. You have the floor and should have control.
Excellent. Thank you, PJ. Yes, so welcome to everybody. Welcome to the webcast. Firstly, can I just say thanks to Lainey for taking time out of a very busy schedule to join me on the webcast today. Before I hand over to Lainey to talk about really the lessons learned on deployment of the communications platform, I wanted to spend just a few moments introducing Trilliant, the company, giving you a little bit of background on what we do and what we're about, and then introducing the communications platform system, which was the system that was deployed for CMP, Central Maine Power, up there in Maine. So, first of all, let's talk about the Trilliant introduction. So we're a Silicon Valley company based in California. We have operations right throughout the world. Our initial customer base in the US expanded out to a large client, British Gas, in the UK. And we're now expanding out into Asia Pacific and across the globe. We have quite an extensive partner network of technology partners to make sure that the communications platform is fit for purpose for the utility customers around the globe, and key partnerships with GE for their software as a service offering, and also Alcatel-Lucent as a key partnership for us. We're a privately held company with strong global investors. Both GE and ABB are investors, along with the other investors you see in the top right corner there. I think we're fairly unique in having both of those large industrial companies as investors in Trilliant. So, the global footprint, as I said, started in North America. We've expanded out into the UK and across Europe, and also into Asia Pacific. As a combined consumer base, working with those utilities around the world, that collectively represents over 100 million consumers across those utilities that are working with Trilliant. Very proud of a number of global awards that we've received. We were the recipient of the Global Cleantech Award for 5 consecutive years, and we're expansions into Asia has recently won us the Technology of the Year Award, which we're very proud of. And most recently, in 2015, we won the Frost & Sullivan Global Distribution Automation Communication Devices of the Year. So those are awards we're rightly proud of. As the continued expansion goes, we're expanding into areas right across the globe, with probably Asia being the biggest expansion opportunity for us right now. So a couple of words really on the platform. This is quite a busy slide, but I want to just give you an idea of the main components of the system. And I think if I start down here in the right-hand corner, the software suite, the head-end system, is called the Trilliant Unity Suite. And really that controls the network element management system, and also the main functionality for bringing the meter readings and the data back across the communications platform. That typically will be connected out to a central device, which you can see in the middle of the slide there, called a gateway. And unique to Trilliant, that operates at 5.8 gigahertz, giving us a wide area network with very high bandwidth and low latency. And that enables us to connect devices at that tier of the network which are relevant, that need that kind of latency and bandwidth. So typically that'll be distribution, automation, SCADA type systems, CCTV for substation monitoring and automation, and Wi-Fi hotspots can be set up on that tier. Those gateway devices communicate out to devices called extender bridges, and they're called bridges because they bridge the 5.8 network down to a 2.4 gigahertz neighborhood area network, which again enables us to connect devices in which are relevant for that tier of the network. So typically advanced metering infrastructure for smart metering, but increasingly other applications such as street lighting, traffic management sensors, some distribution devices which don't require the low latency and high bandwidth. Street lights and other devices can be connected at that tier. That's a quick kind of walk through the overview, and I know Laney's maybe go into some of the details on how this specific system benefited central main power. But really, our unique offering, I think, is that it's a multi-tiered wireless communications platform, really for the Internet of Things, which can be smart grid, smart city, or indeed smart metering. So specifically for CMP, the solution was deployed across two meter types. Lenderson Gear and GE were the chosen meter vendors for CMP. We support both those meter types, but also many other meter types, in fact. And then also the distribution equipment, as you can see, is connected to the WAN tier, the 5.8 gigahertz broadband mesh. The Unity Suite platform, which is a software suite, allows integration through to many downstream applications, including obviously the meter data management application, but also asset management systems, SAP, global information systems, graphical information systems, and also the distribution side for the outage management system, which has given some great benefits and was tested very early on with Sandy and other storms which came in just after we deployed. And just a few details really on the network there. We have around 130,000 meters per network takeout point, and in terms of range, the 2.4 gigahertz NAN links are up to about 35 kilometers point to point distance. That was kind of maximum distance as we measured in the field across the network. We also have the ability to introduce a home area network on the back side of the meter. That's embedded functionality, which is available to CMP as they wish to deploy that, or customers wish to deploy that sometime down the line. And obviously we have full capability through the meter at time of use, demand side management, net metering, etc. So how did this kind of project roll out for CMP? This is a kind of one slide summary before I hand over to Laney to talk in some more detail. But essentially, as a Advanced Recovery and Reinvestment Act funded project, it was quite highly audited, and we were very pleased to make a very successful deployment on time and on budget. It's been used somewhat of a showcase for the DOE's RF funding, which means I'm very happy to share information about the project, and I know Laney spends a lot of time giving information about the project, and we're happy to support that approach. The project won JD Power satisfaction scores for 7 years. I think generally these scores are very jealously guarded, and we wanted to make sure that as the project was deployed, those scores were in fact maintained or in fact increased. As I mentioned, just shortly after the project went live and was fully deployed, we had a couple of storms hit the east coast of the USA here and Maine. Irene and Sandy came into town and did a lot of damage, pulled a lot of infrastructure down, and we were very pleased how the system performed very early on with the support to the outage management efforts and operations that CMP took place, and we're going to talk about those in some more detail. So hopefully that's give you a little bit of an overview of what Trilliant are about, the system at the very highest level, and a very brief introduction to the project itself. I'll now hand over to Lainey Brown, who will talk a little bit about some more of the details of the actual deployment and the lessons learned.
Thanks,
Lainey.
Thank you. Appreciate that, and thanks for introducing us. And I think you hit on some of the key areas that I think we like to talk about, in particular customer service, our customer satisfaction, and our reliability. And I'll talk a little bit about how those are kind of the key components as we look at our smart grid strategy. So maybe first a little bit about Central Maine Power and Iberdrola. And then we'll move into talking about kind of lessons learned and where we've gone really since project completion. So Central Maine Power it has about 620,000 customers. We're located in the state of Maine. We cover about half of the territory, but probably about 3/4 or 80% of the population. There's a whole lot of Maine that doesn't have a lot of people. I think importantly, we are a subsidiary of Iberdrola. And a lot of the things that I'll talk about today really are driven by the unique opportunity that Iberdrola provides. It's the 5th largest energy company in the world, and it's the largest renewables company, wind renewables in the world. And so we have a lot of interesting opportunities to leverage the experiences and the knowledge that's across Iberdrola, and a lot of that has come into play in our smart grid strategy. As Chris had mentioned, we did win customer satisfaction, J.D. Power's customer satisfaction 7 times, and one of which was actually during our deployment, which was really important as we looked at making sure that we continue to improve customer satisfaction and customer service through that, and also reliability, a critical component of what we do. As we look at our smart grid strategy, we put together a 10-year roadmap with the AMI investments, as Chris had just talked about, is really foundational to that smart grid investment. And some of the key things that we would say fundamental to our smart grid strategy are the communications network that we've put in place. We have a wide area network, as Chris had mentioned. It's Trilliant's network that covers our entire service territory. So 24,000 distribution circuits, 11,000 square miles. And that has been leveraged as we move forward on automation, building off of the smart meter network. We did roll out our AMI starting in 2010. So the data that's created from that network, and also now through automation, the network and the data are the critical foundations of our smart grid strategy. And one important thing that we continue to try to do is, once that project was completed, we look to optimize those investments, the data, the network, to continue to look for operational efficiencies, reliability, and customer service, enhancing customer service and satisfaction. And those are really the fundamental value and benefits that we continue to seek to deliver through those investments. As Chris had mentioned, we finished our AMI deployment in 2012. And since then, we've continued to look at ways to optimize that investment. And I'll talk through the benefits we realized really at completion of the project, and then the ones that we continue to, the benefits we continue to achieve, and also how we continue the optimization and planning through pilots. Our expectation is by 2020, 10 years of that vision, that we'll have a fully integrated platform, including an integrated energy control center, fully optimized automation, and moving towards innovative rates and on billing options as some of the fundamental components of that. We're also, I think, one of the first states to actually implement a non-transmission alternative, so looking at alternative distributed energy resource solutions, and we're using our smart grid information and data to manage that as well, and I'll talk a little bit about that. So just a kind of an overview of our smart grid investments. As Chris had said, we were very fortunate to receive funding from the Department of Energy. We had a $164 million investment in AMI, and we completed that project in 2012. We did complete it on time and on budget, and in our assessment, we also achieved, I think, over 90% of the benefits that we had forecasted for the first year. We've also been moving forward with grid automation, with 99% of our substations automated, and 38% of our three-phase reclosers automated by the end of last year. And our plan is to basically have full automation both for our reclosers and our substations by 2019. Some of the benefits that we realized, and we measured basically at the end of 2012, we have now, we read 99.6% of our meters annually. We actually had a regulatory requirement threshold for meter reading, and subsequently, since we've rolled out AMI, we no longer have that regulatory metric because, to some extent, it's not necessary anymore. The thing that's really important is we've looked at the operational benefits and is just how they marry with customer benefits. And one of the core things that we did when we implemented and planned for our AMI rollout is to look at how do you make sure that you're not just automating existing processes, but you improve them? And how do you make sure that as you look at operational benefits, you're also achieving value for customers as well? So one of the things that we've seen in the significant reduction in meter reading estimates is obviously reduced bills, which is actually translated to reduced calls as well. We've avoided over 300,000 truck rolls. And what we can do now is reconnect for non-payment or for new service within 30 minutes. We've also automated that process, so if a customer gets disconnected, they can actually pay online and get reconnected after hours. So significant value for our customers. We can process up to over 2,000 remote orders a day, so operating at scale basically to support all of our customers. And what we've seen as well is that historically, as an example, during major storms, we may have had to shut everybody down basically and redraft our resources to help out in other areas of the territory for major storms. And what we can now do is continue to operate the system and still dispatch our resources to help out in other areas. So, I think it's helping us really optimize the resources that we have while continuing to serve our customers and to operate efficiently. We've reduced over 1.7 million miles, and we can also schedule service orders, so an on or off order by the hour. So if a customer wants to move out, say on Friday at 3 o'clock in the afternoon, we can do that. We can also basically close out an account if a customer calls and looks to close out their bill immediately. We can do that as well. We've got faster outage assessment and more informed customer information during that process. We are putting in place this year outage notifications with ETRs so that customers get on the minute really information about their customer information, really driven by better information from our smart meters. As I had mentioned, we've looked at 2012 and our benefits that we achieved basically at the end of the project, but then we also said, how can we continue to optimize the assets that we've put in place? And so we took a snapshot really at the end of 2014 to look back at the benefits that we've realized because of the investments that we've made in smart grid. And they are across a range of benefits. The key ones, as I mentioned, reliability, operational efficiency, and enhanced customer service. But what we've also seen, interestingly, is an animation of the market and continued sustainability, which is a critical thing for Iberdrola. So just a couple of key points about what we've seen in terms of impact on reliability. We have 7 times more information because of the automation and our smart meters today to assess and restore on outages. And what we've seen actually is we had forecasted what we believed would be a reduction in outage time with automation, and we've actually been able to validate that. So 20% reduced outage time based on our automation of reclosers and faster assessment with AMI. But we've also been able to basically leverage the AMI system, ping meters, and get a faster assessment without rolling a truck. So avoiding, or faster restoration, but avoiding the truck roll to determine whether trouble, customer is on or off. We've been able to do that significantly faster with the capability of pinging our meters. We have achieved the savings threshold that we had put forward and assumed, but we had also seen a 90% reduction in safety incidents. We've seen significant reduction in high bill calls and obviously significant improvement in meter reading. When we put forward and completed our AMI project, we also had a number of tools that customers could use to better understand their energy, and one of them was an energy manager. We've seen the enrollment in that. It's our online portal. We've seen that double in 2014. And we've also expanded our offering to basically have targeted portals for our business customers, our residential customers, and our C&I customers, each providing kind of a unique view on how those customers might manage their usage. We've also conducted a pilot to look at really how weekly alerts with goal savings really provides good information for customers that drive action. So in our pilot, we saw a 2% reduction in usage, and we're launching for all of our customers bill alerts this year as well. And we're excited about that opportunity, and we really think that that gives customers a tool to understand, without necessarily having to take a lot of action, to understand how they're using their data, and will drive customers to the portal so they can dig in a little bit more deeply. In Maine and for CMP, we're actually the first utility to settle on a daily basis with customers' actual usage as opposed to profile data. And what we've seen is really kind of changing the market in Maine. We provide historical information and an ICAP tag to suppliers on behalf of their customers, and we're receiving 100,000 requests over a year, so almost 10,000 a month, from suppliers requesting that information on behalf of their customers. We believe that's really driving a robust and more competitive energy market in Maine. And we also know that, in particular, C&I customers with competitive energy providers are saving hundreds of thousands of dollars by being able to manage their ICAP tags that are now individually developed based on our AMI data. So it's sort of an interesting evolution of the market in Maine. And we're also in the process of developing what we're calling a supplier marketplace, where customers can opt in to have their data shared, and suppliers can basically access that information and help provide more customized or more relevant information, whether it's bids or whether it's support around ICAP tags to help customers more proactively. So we're really interested to see the development of that market basically once that marketplace is established. Because this is a continual effort in terms of optimization, the other thing we are launching this year is looking at pilots that we believe will then transition to full-scale, or we're testing for full-scale implementation for 2016. And the program that we've set up is really continuing that optimization. So full initiatives in 2015 and pilots that will then move into and leverage optimization in 2016. So we'll talk a little bit kind of generally about the pilots that we have initiated, and then I'll dig into a little bit more detail on some of those. We've looked at, the network as a core asset and the data as core assets. And so we're looking at leveraging all of those components of the network to provide and test operational efficiency, customer satisfaction, and reliability. On the network side, we're testing auto-sectionalizing, and both in terms of utilizing the network that we've got and also looking at different ways of approaching sectionalization. So we'll be testing that with the intent of kind of testing new standards that could be leveraged throughout our service territory. The second is focused on the meter, basically developing a voltage optimization roadmap. In Maine, it's a little bit unique in that we have, we look at supply side benefits. We've got 3 people sitting at the table. Basically, because we're deregulated, we work with the state on supply, and there's also a separate efficiency entity. And so voltage optimization kind of crosses all of those. We have the technology and the systems for, and obviously control of the meters and the network, but we are also, need to work with all the parties to look at the benefits from voltage optimization in BOFAR. And so we're basically queuing up the information so that we can understand bellwether meters and the information, capturing that information that'll give us insight on what's going on in our network, but then we can leverage that basically to support BOFAR optimization. And then we've got 3 initiatives around the data that's provided. One is data visualization, so kind of putting our toe in the water, if you will, around analytics. The second is an energy manager seminar. As I mentioned with our ICAP tags and the information, we know that large industrial customers are really taking advantage of the information that we're providing, and we want to make sure that we can continue to bring that value down as you look at medium-sized businesses and really across our customer base. So the Energy Manager Seminar is basically about what are the right tools and information to help more of our customers leverage the data that we have available to them. And then the third one is university collaboration. As I mentioned, we have implemented a transmission alternative pilot in the Booth Bay region in Maine, and we're looking at and trying to understand as we look at the different DG options or DER options, both passive and active, what are the performance levels and what's the forecast or impact if we look at that data, both with AMI, automation, and substation information, as well as basically looking at the information from solar and efficiency programs. So I'll talk a little bit about those initiatives in more detail. Our data visualization proof of concept, really the initial component of it was first getting our internal clients, if you will, to understand the value of the data that we have and kind of share that beyond maybe those who may actually already be using it. So our customer service organization today uses our AMI data every day, both for supporting customers, for billing, et cetera. But it had not been highly used beyond, say, customer service. And what this tool has done is basically was developed specifically for our distribution planners, and it brings together SCADA data, recloser information, and also our AMI data, all in one place in a way that's obviously is graphically presented, building on top of our GIS system, to help planners basically troubleshoot and understand where there might be an issue on the line, when they can potentially take action, or maintenance action can be taken. And so it brings together for the first time across a lot of data silos and presents it for the distribution planners in a really easy to understand way with quick filtering capabilities. And what we've seen is this has been highly successful for our distribution planners. We really just developed a prototype in one area, but they're able to get a sense for the value it could provide. And what they've said is basically information that may take 6 to 8 hours to collect, they can now do, see basically in 5 minutes or less. So it could really improve the efficiency when this goes to scale. It provides really a better understanding of the information that we have, particularly AMI data that had not, as I mentioned, had not been used before. And I think it creates an opportunity then to build off of this prototype and this pilot to create a better understanding of how we can continue to use the AMI data and continue to use this tool to build upon for future use. So that's one of the things, as an example, we're leveraging this data visualization proof of concept to 2006 in action is basically to develop an analytics roadmap with AMI-focused use cases. And that's how we're continuing to kind of leverage information and actions we're taking for ongoing optimization. The Energy Manager Seminar, as I mentioned, is really reaching out to non-residential customers, primarily our medium-sized customers, to help them understand and manage their peak usage, basically have the opportunity to reduce their ICAP tags, which in some cases can be significant. We know for our largest customers, it can represent as much as 28% of their annual costs. As I mentioned, we've seen some of our large businesses save up to $100,000 to $200,000 a year because they've been able to manage that ICAP tag. So it can have really meaningful impact and savings for customers across the board if they can manage their ICAP tags. I think this also just builds off of what we know about our customers, and know about customer satisfaction, which is really they want to understand how they can keep their costs low and how they can manage their usage. We launched our Energy Manager specifically for business customers in December of 2014, and we wanted to test also the ways that we could be measuring supply-side benefits. So, we were highly focused when we launched in 2012, highly focused on achieving the operational benefits that we had full control over. But the big question was, what are the supply-side benefits? And so this is helping us really dig deeper and provide more value for customers on the supply side. We launched this webinar. We had, I think, over 10 customers kind of across the board participate. We had executed both a pre- and post-seminar survey to understand and gain more insight in terms of do we change our customers' understanding of how they could use these tools, of what an ICAP tag is, and if they could continue to take action going forward. And I think the next step for us is then to develop more content and material, both that we can post on the website, but that we can also share and continue to educate our customers on the value that that information can provide in saving money. So we'll conduct another seminar this year, and I think we'll be leveraging a bunch of probably regional kind of business-focused trade shows, et cetera, to get this information out. But we did find it, customers absolutely found it of value, and it's an ongoing, I think, education for us on how we can continue to engage customers in this area. And the last pilot I'll talk about is the university collaboration. So as I had mentioned, we have a non-transmission alternative in the Booth Bay area. It's both a combination of passive and active distributed energy resource capabilities. A fair amount of efficiency programs were launched in that area, solar, as well as some storage and a generator. And what we wanted to understand as we looked at this this pilot, with the expectation that we actually have many, many more in the pipeline, is how are those resources, how are they basically, what's the performance as compared to the forecasted performance? Are they contributing to the reduction of peak as envisioned? And how do we leverage our data to understand what that looks like? The other thing that's critical from a non-transmission alternative perspective is forecasting is even more important. So historically, we would look at a forecast at a system-wide level, and then basically with some econometric model changes, we might look at and push that system-wide forecast down to a substation or regional area. But when we're developing a non-transmission alternative, that's just not detailed enough. And what the data, AMI data and our SCADA data is allowing us to do is really at a circuit and substation level get a better forecast. And we were working with Binghamton University basically to crunch our data and analyze it for us. They've got a lot of smart PhD students who are helping us look at those two key things, so our forecasting information and our DER analysis and performance, to understand then how we can leverage that information going forward so that our forecasting information and our M&V activity is stronger and will continue to evolve really as we roll out across multiple non-transmission alternatives. So a strong engagement with Binghamton University really to help us crunch that data. And that's ongoing, and we expect the results of that really by the end of this year. So as we talked about the smart grid investments that we've made, and as we see really the evolution of energy looking at non-transmission alternatives or looking at increased competitive market, or really changing customer expectations or needs, we really believe that we've put together a platform that can help us as kind of the energy future evolves, whether it's more accurately forecasting PV performance based on our AMI information, or improvements around reliability because of the automation in place. That the platform we put will continue to evolve, and we'll continue to look at and optimize the assets that we have put in place. So that's the end of my presentation, and I think Chris is our Q&A guy. So Chris, I'm going to pass the baton back to you.
You bet. Thanks, Lainey. Great job. I think there's a lot of great information there. We've got a few questions in the WebEx here. There were a couple initially. I'll take them out of order here about ICAP and what ICAP means.
Yeah.
As I understand, it's the installed capacity tag. Maybe you could talk about that just a little bit.
Yeah, sure. It's exactly right. It's an installed capacity tag, and it's basically the charge that all customers pay. They may or may not necessarily know. Some may be more aware of it than others. But basically, they to reserve or ensure the capacity is available at peak periods. And it's basically allocated for all customers. Historically, it was based on profile information. So we used to, for residential customers, C&I customers, et cetera, where we did not have interval data, it was based on statistically valid sample sizes of those customers, of the different customer classes, and then applied on an annual basis.
Yeah. So the savings kind of come from having the interval data and being able to flatten the load profile and reduce the charge.
That's exactly right.
For the
Yep, exactly right. So so customers, it is based on peak hour during system peak hour, and the tools that we have in place and are basically allow for an understanding of or anticipation of when that system peak may occur, and then what actions you can take basically to reduce your demand during those peak periods. And I'll give you an example. We have a bakery in Maine that is actively watching this, and they basically shut down their baking during the peak period. And those bakeries actually saved $90,000 off of their customer bill because they reduced, basically nearly all usage was reduced during that peak period. And that's just an example of actions that can be taken to help manage that cost.
Great. Okay, there was another couple of questions really around the communications system. One was, just read it here, did C&P have to purchase additional radio bandwidth to accommodate the new wireless infrastructure, and if so, was that difficult? Maybe I can take this one.
Yes,
so there was no additional bandwidth required to be purchased. Both the 2.4 and the 5.8 gigahertz operate in the unlicensed band, and therefore there are no additional charges. One of the criticisms which is often levied at unlicensed is one around interference, but the reality is that interference on the ground can be very easily managed around by just shifting channels and operating at slightly different frequencies. So we've never had any issues, and I think Lainey, you can attest to this, of interference causing a problem on the network in the unlicensed space.
No, it's never really been a major issue.
Yep. There was a second question here, really on the comms system also, around what actual communications technologies were used for the meter communications, RF mesh, cellular, PLC, etc. Can you describe the decision making on the logic for selecting each particular one? Maybe I'll take that one. So the technology used is RF mesh, both for the meters and the wide area network, as the backhaul and the distribution or low latency, high bandwidth tier. The system itself can handle cellular and PLC also. We do see other customers that, for a variety of reasons, want to use a mix of communications technologies, and the Trilliant system can clearly handle that hybrid approach if that's so desired.
Yeah, and I can maybe to take a little bit about the decision making on that. So we are there's two things maybe. We are a pretty rural state. Just for some metrics, we have about 1.5 customers per transformer, so pretty distributed. And we also it's gotten better, but when we first started to deploy the network, we knew that we couldn't rely on cellular. There's still pockets in Maine that have absolutely no cellular coverage, and so some of the infrastructure was not built out enough for us to rely on that, which is one of the key reasons why we selected Trilliant in terms of the wide area network. We were able to put in place, as Chris had mentioned, a wide area network that covers our entire service territory, and it's a high bandwidth network, and so we use that for our smart meter data collection, and then we also now use that to support our automation investments as well. So for our new build outs for our reclosers, we're leveraging that network and transitioning some of our older automation to that network as well.
Great. Okay, there's a couple of questions around the Energy Manager and the energy savings. Specifically, is there a report which details some of the actual savings which would be available? The 2% figure was mentioned specifically for Energy Manager?
Yeah, so we do have, there's two reports, I think there might even be more than two, out on the smartgrid.gov website. There's a case study specifically about CMP that provides an overview of the savings that we've achieved. We also have a report that was a study basically of the results that we achieved through the Bill Alerts program, and I'm happy to provide that. I don't know, I'm not sure the logistics if we can post it, but if I think if you want to send me an email, I'm happy to send that to you, and that's publicly available basically on the results of that pilot for the Bill Alert. Right. Yep.
Perfect. And then there was a couple of questions around the opt-out change. So question, how did you handle the customer opt-out change? Right. And I guess for people that hadn't got the background on this, maybe just to give a little bit of a background, what happened was there was a representation of customers that did not want to participate in a smart meter deployment, and the regulatory process kind of went through. That was agreed that customers should have that option, and so that was mandated by the regulator that CMP needed to provide that option for customers to opt out. I guess from a technology perspective, we modified the product to enable us to remotely switch the radio off in the meter and essentially turn it back to a manually read or a dumb meter. So from a technology perspective, we can handle an opt-out scenario. I don't know, Lainey, whether you want to talk more about the the challenges from a regulatory and a program perspective.
Yeah. So when we actually installed the day we installed our first meter was the day we got our first request to opt out. And we worked with, as Chris had said, we worked with our regulators to basically develop a program so that customers did have the choice to opt out. It was cost causer, so customers have to pay to opt out. And we had at the end of our program, we had approximately I'd say 8,500 customers who had opted out. We've seen that actually continue to decline since 2012. So I think we're under 7,000 customers who have opted out of the program, so it's continuing to decline. But we do charge customers, depending on your choice of opting out, between $10 and $12 a month to opt out of the program. And we also were very proactive in working with communities and counties, doing a significant outreach program, so that as we deployed during the deployment period, you know, we gave every city, town, county, basically, information about what the actions we're taking, and tried to address any concerns they may have before we moved into and basically started installing meters in their towns. And that actually proved to be a highly effective program just to engage communities and engage customers. So I think overall, as I said, from a customer satisfaction perspective, we actually won a J.D. Power Award. So our overall customer satisfaction was not impacted, and I think communities really appreciated that outreach program. And at the end of the day, there are going to be customers who don't want a smart meter, and the opt-out program basically provided that opportunity for customers, you know, with a fee.
Yep. And I think that's still a very low number, isn't it, the customers that have actually...
Yeah, it goes down about 30 to 50 a month, actually.
Yep.
Yep.
Okay. There's a question here more kind of strategic about Iberdrola USA, and are the lessons from the CMP deployment being used elsewhere in the Iberdrola group, particularly those lessons applied to New York REV?
Yeah. So I am actually actively involved in the REV proceeding in New York and participating on a market design technology platform stakeholder group, where these lessons learned are applying. But yes, I think we're absolutely looking at, from a AMI perspective, you know, assessing the value that we gained in Maine, and that's informing our cost-benefit analysis in New York, and also our approach around automation generally, you know, at a substation recloser level, is also informing the New York activities where automation is rolling out. So it's definitely informing that, and definitely, you know, looking to provide that insight that we gained in Maine into the REV proceeding.
Great.
I think I would just say, just in particular, in New York, market animation is a really key area, and some of the questions about how can you get a better understanding of, and how can you optimize distributed energy resources? That's a big question in New York, and obviously the experience we have in Maine around the non-transmission alternative is helping us in that case. And also market animation, what we've seen in Maine in terms of how suppliers have used that data to the benefit of the customers and suppliers. We think those in particular are two highly relevant components of what we've done in Maine that will apply to REV.
Yep. And there's a related question here which asks specifically, are there any plans for dispatch consoles used for energy trading, dispatch or command and control? I guess this is taking the concept of, you know, in REV and seeing how that may be applied. Yeah.
So you know, we look at what's envisioned in REV is basically utility as a distribution system platform. And we feel like, to some extent in Maine, we've done a lot of that already. In the three areas that are focused in New York: integrated system planning, grid operations, and market operations. And so a lot of what's envisioned in those roles in New York, we have actually had experience. You know, integrated system planning, we've got, I think, 100 megawatts of potential non-transmission alternative solutions currently in review in the regulatory process. So that's, you know, that's something that's really becoming a core part of how we do system planning and how we leverage the data. And I talked a little bit about, you know, some of the lessons learned and learnings we're trying to gain from what we've seen in our pilot, and that fits under the integrated system planning. Grid operations, obviously, as we look at reliability, more data to drive improvements in reliability, and as we look at the pilot on how we manage both assessing performance and potentially dispatching the active resources in the Booth Bay area, that's a big piece of the grid operations. And then our market operations, again, what we've seen with suppliers and leveraging that data both from a historical usage and from an historical ICAP perspective to give customers better bids, more competitive information, and helping customers manage their usage, particularly peak demand. We think those are all kind of key elements that that fit the model, if you will, as envisioned in REV for the DSP.
Yeah. And then just following on from that, there's quite a specific question which says, does AMI allow for extension of demand-based metering to residential customers? I think the answer to that is yes. It's a net meter where import-export meter can be accommodated. And then following on, is CMP considering a demand-based tariff for residential customers, particularly those using net metering for distributed energy resources? So I think what this is getting at is, if a residential customer had distributed energy resources, photo cells, whatever, is there a tariff for them to be able to participate in that model?
Yeah, and I think there have been discussions in Maine for sure around demand-based rate structures. I think those are still in discussion.
Okay.
Yeah.
Okay, just moving tracks a little bit. There's a host of questions really around the outage management piece and how that was managed, specifically how the system was used to support outage management efforts and what was learned from the storm experience, which was a little bit of a baptism by fire.
Yeah, I think it absolutely was an evolution, and I think maybe it speaks a little bit maybe of how people learn how to use data and accept data. But we were probably, and Chris, keep me honest on this, maybe 50 or 60% of the way through our AMI deployment when we got hit by a major storm. I think it was Irene, and
yes.
And one of our executives said, "Isn't there any way you guys can use your AMI data to help inform about outage?" So within about a 24-hour period, we basically looked at capturing event information and updating them, uploading them into our outage management system and our work management system to create and clear trouble orders, actually, which for us trigger outages. And so that was I think maybe to Chris's statement, baptism by fire. But what it really provided us is an opportunity to figure out, one is to quickly prototype, I think, through leveraging AMI event information and AMI data, and also the recognition of the value that it could provide pretty early on in the process. So we have part of the development that we had with the AMI program was actually the development of a GIS, update of our GIS system and our OMS system, and we took pretty deliberate steps in integrating the AMI event information into our OMS. So the first step we took was basically to have in real time all of the AMI on and off events incorporated into as a layer basically in our GIS, so that as folks were looking at and understanding what was going on from an outage perspective, they could see that as another data point, and they could take a look at and understand what was going on using the AMI data. And that first step basically allowed, I think, the folks in our outage group to get a comfort that the information was solid, they could trust it. And then once kind of there was that comfort level, we moved into integration of AMI event data into predictions. And kind of in parallel, same thing around basically using our ping capabilities to verify meter power on. So same thing, have integrated that, and it's a part of the tool that we use for storm restoration. So those are, I guess, kind of the key tools that we use.
Yeah.
Yeah.
I think I'd just add that, as when that very first storm came in, the system wasn't fully deployed, but we still had some benefit from the data that we did have available.
Yes.
And as things have evolved and the system has matured, and I know we've worked very closely on changing the system, improving it, so pings come in a lot quicker, within seconds rather than minutes now. The interfacing has been improved to allow tighter integration to downstream systems. Seal, the smart energy access layer, provides that kind of level of integration for us. So, we tried to work with CMP to improve the product in that area as well. I think we've had some real success there too.
Yeah, absolutely.
Okay, I think that's probably bringing us to the end of the questions. There are a couple more here. One specifically on. Is CMP a summer or winter peaking utility?
We are summer peaking.
Summer peaking, okay.
We were winter, but we're now summer.
Okay, I think that was a prequel to the demand energy resource questions which came in.
Yeah.
Okay, I think that's pretty much the end of the questions. So I'll before I hand back to PJ to close the session, can I just take the opportunity to thank Lainey for her time? I very much appreciate that, Lainey. I know you're extremely busy right now with all the New York Rev and many other things you have on your plate right now.
Thank you, Chris. I appreciate it.
Thanks for everybody for joining the webcast. I hope it was useful. My contact details are on the final slide there. If please feel free to reach out to me for any follow-up information or indeed to get a hold of a copy of that energy savings report. I'd be happy to facilitate that. So thanks again. I'll hand back to PJ.
Thanks, Chris, and thanks, Lainey. Fantastic presentation. For our audience, we hope you've enjoyed today's discussion. As you log off, please take a moment to complete our survey and give us your feedback so we can continue to provide you with quality content. Thank you for attending, and this does conclude today's presentation.